let's hear from you guys. Some thoughts from last week. Let's see, is Aubrey here?
I kind of like we just talked about a little bit, but the stability of orbits and like they wouldn't be faster how they would go off their chains.
Off their chains, yeah. I like that analogy, chains, by the way. I'm going to make the case to you that it's a much better analogy than bent space-time, which is the most popular one of the day. That'll make more sense after we talk about time, I think. Anybody else have thoughts or questions about that one? Yeah. Tell me your name again, too. I'll just...
Shane. This was like just kind of got me thinking. So like the Earth being a Goldilocks planet, and the reason why it is that way is because it has to be at a specific area close to our sun, and like all the science has to be specific about it. But there's other Goldilocks planets out there.
Yes.
How common does this, I don't know, kind of like word it.
Like how
Does this like miraculously happen where it's like to the degree like exactly where it's supposed to be?
I mean, the difficulty of answering that question is that the universe appears to be about as big as we can see, and maybe bigger than that. Probably, I would guess, bigger than that. It gets bigger every year, it seems like. So the answer is quite common. There's a lot of, and we're going to talk, we have a week dedicated, I think, to astrobiology and to the search for life in other places. And we're going to look at the constraints that you would, but obviously the biggest one is liquid water, right? And that's what you're talking about. You guys heard this Goldilocks thing before? We're like just at the right distance from the sun where we're not going to freeze over, but we're not going to boil. We're not too close like Mercury or Venus where we're going to boil off our water. And there's something about liquid water that is critical about everything that's happening in this classroom right now. Water, I think it's my favorite molecule, if I'm going to be super nerdy. It can do all sorts of incredible things. It can bear incredible tension. It can freeze into a solid, which actually is bigger than if it's a liquid, which is completely unique in the chemical world. It's usually the opposite. So it's weird stuff, and of course it solubilizes all the things we want it to and doesn't dissolve all the stuff that we don't want it to. So it's pretty cool stuff, and it seems to be critical, but there's some other players too. So there's more than just the distance. There's a lot of chemistry that we got to look at, not in the boring sense, but in terms of like, well, what can we see from here in terms of light signals that's going to indicate that it might be a habitable place? And I don't know if I said this before, but I think that there's a good case to be made that the entire reason we're even still interested in space and the stars is because we have some part of our brain that's like, we should probably get off this rock at some point. You know, it's a great place. I don't think we're in any hurry to get off of it, but you know, sometimes it's not so hospitable. This entire planet was covered in 5 miles of glaciers at one point, which is a really, really weird piece of history that people don't tend to deal with. What was happening? Was it like, the theories are bizarre. There's none that are really satisfactory, but I was talking to that dude, that astronomer, Sean Raymond, about this, and it's like, well, could the orbit have been in a different place at that time where it was really cold and then shifted back? I mean, maybe something crazy happened, but that doesn't seem to have ever happened again. But could it happen in the future? Maybe. So hopefully we're technologically prepared enough to, you know, make some sort of a backup hard drive somewhere else at least. And of course, Elon's like trying to do that with Mars. And when we get to Mars, we'll talk about the issues with pulling that off, particularly because it doesn't have a magnetic field. And that's the other piece of the puzzle that makes this a really nice place to live. There's a lot of terrible, nasty radiation and stuff like that flying in all the time towards us from the sun, from other suns far, far away. And part of the reason we can live here is because, and part of the reason that doesn't just chop up our DNA is because we have this nice magnetic field. But we don't even know what magnets are yet. We'll deal with that, and then we'll start to make sense of all these things. But yeah, that's a really good point. Okay, who else we got here? Nolan, I don't have anything from you. I thought I saw you earlier. Yes. Got any ideas, thoughts?
Not really.
Uh-oh.
Kind of busy this week on my accounting homework, so I haven't been able to do this last week's stuff.
What about, you were in class though. Any thoughts from last class?
Last class, yeah, I thought it was interesting, just kind of how you mentioned, the Pope that exiled Galileo, and he put him on house arrest. I did a little bit of research into the Pope that did that. And I mean, the guy wasn't really that great of a guy. He kind of caused some wars, caused a lot of, he got too, I guess, ingrained into the political aspect of things. He kind of let some power go to his head. Wasn't really leading the church in the right directions.
Interesting.
So,
Yeah, that was a weird piece of history where the church took over all of the financial, economic, and state duties for a while, which doesn't seem to have been the case. On the other hand, there was like a surprising lack of slavery during the medieval period. And so there was an interesting trade-off there. Of course, as soon as the state came back, then slavery reared its head. The state took over money again and debts and stuff like that. There's a really interesting history. What pope was that, by the way?
I think it was Pope. It wasn't Gregory. It was this other, and like really all he's known for is putting Galileo.
Oh man, that's something you don't want to be known for, right? Yeah, Galileo, but Galileo was a real troublemaker too. I think he kind of was asking for it. It's kind, I can't think of a better analogy than just trying to argue with a cop when you get pulled over. It's just like don't do it. It's not gonna, especially don't refuse. The cop's like, get out of the vehicle. The last thing you want to do is say no, right? Like how does that ever? It's funny because if you look at like police involved like shootings and stuff like this, it's never like burglars who get shot or like bank robbers. I mean, sometimes they do, but it's like always people who are like, not always, but it's often people who are like trying to basically say they won't go with the authorities. So look, authorities, take them or leave them, but they do have authority, so go with it if you value your well-being. All right, how about Caleb? Are you here?
Which one?
Oh, that's a good question. Zin.
Okay, that's me. There's a few things I found interesting. You kind of mentioned already, after class, we talked a little bit more about like orbits and stuff and how specifically you posed the idea that we talked about how our solar system looks so different than what you would like expect from like looking at other solar systems. And like why that might be, and maybe at one point like instead of just a comet like from beyond the Oort cloud traveling through, maybe there was like a whole planet that came through, which would have really screwed orbits up. I found that really interesting. I still do. I also really liked, I think this was in the reading, but reading about how they found Neptune based off of the math of Uranus's orbit and how much it was getting pulled by Jupiter and Saturn, and they're like, wait, there should be another force here.
Yeah,
Doesn't quite add up.
I didn't get to that one, but I was going to mention it today. But now that you already did, maybe we can just talk about it.
Yeah. Anyways,
Yeah.
A lot of last week, I really found orbits and stuff and how they get screwed up or not. It's really
Yeah, it's an underappreciated topic, I think, how they get screwed up or not. I really want you guys, I think this will be hit hard by the end of the semester. I think that the next revolution in astrophysics, and especially planetary formation sciences, is to start thinking really evolutionarily about these bodies, right? And this is going to become really apparent when we start investigating the most common type of planet in the universe, which is this thing called a super Earth or a mini Neptune. So most, and I don't want to belabor this because we have some slides devoted to it down the road, but there's a planet it's somewhere between the Earth and Neptune. So we'll talk about Neptune and we'll talk plenty about the Earth. They have a lot of, this water. The Neptunes have a lot more ammonia. They have some different solutes, and it's in this weird slushy kind of form. It's not quite liquid, it's not quite gas, it's weird. But in between that, it turns out that's where most of the planets tend to be. And the weird thing is we don't have any of those in our solar system. So there's a couple of possibilities. A, maybe the solar system formed without them. B, maybe they left. That's something that we don't talk about too much. It's an uncomfortable thought, perhaps, that planets just sometimes leave. Or C, maybe they evolved. Maybe something that looked like a Neptune evolved into something like a mini Neptune, and the ways that it could do that, and then maybe evolved from something like a mini Neptune into something more like a super Earth, and then maybe from something like a super Earth into something more like an Earth. You know, these things are very difficult to distinguish, but that's kind of an interesting paradigm shift that, you know, we talked about paradigm shifts. Yes.
When you say it left,
Yeah.
you mean it like fell out of orbit?
Yes.
Okay.
Yes. Yeah, it's an uncomfortable thought, right? Well, if you think about it, I mean, we're cruising, you know, according to this heliocentric model, we're cruising at quite a click. I don't know how off the top of my head, but it's some tens of thousands of kilometers per second. This thing's really moving. And the only reason it doesn't just go away in general is because the sun's pretty big and it's holding on to us. But the balance, this gravitational thing is entirely dependent on how many atoms there are and what kind of atoms there are. So I'm going to refresh this a little bit because I want to make sure that we understand this mass concept a little bit better. But the sun's losing atoms all the time. It's losing material. Let's just leave it at that. The Earth's losing material all the time. And so it makes sense that these orbits do change over time. The question is, how badly do they change? Is it catastrophic? Isn't it? And, you know, textbooks especially, but science in general has a really hard time with these kind of one-off black swan events. We like to think about processes as these nice continuous gradual processes, especially natural processes concerning the Earth and so forth. So we like to think everything happens really gradually, and so we have time to get out in front of it. I think it stems from this deep psychological need to like think we can handle stuff, which we probably can, but the reality of the situation is a lot of scientists, especially people studying evolution, they're realizing that, you know, this nice Darwinian story of like genes slowly mutate over time and stuff doesn't really seem to play out. More likely, the environment changes radically and huge adaptations happen very stepwise, right? All of a sudden, and they call this punctuated equilibrium. It's very likely that the geological past, the solar system's past and all of that could, well, I won't say very likely. It's certainly possible that you could have this stepwise evolution of the solar system as well, where huge changes happen all of a sudden. Sometimes for the better, sometimes for the worse. Obviously, it's a pretty stable place because we were mostly little amoeboids and stuff for billions of years. All of this that we're looking at in the room right now and one another has happened in the relatively former student, relatively recent past. Like, honestly, if you like laid out the history of the planet as far as we know even, maybe it's older than we think, but as far as we know, you know, everything that we're looking at here has been like the last few seconds of time. If that was like a whole day. So, you know, it's been pretty chill enough for this to happen. And there's every reason to expect that'll continue until, of course, it doesn't. And then we'll be looking at a new set of problems. Or maybe it'll get even better, who knows? Okay. Who else do I have here? Is Joe here? Nope. How about Kat? Some of these people might have dropped the class too, I apologize. How about Levin? How about, I'm almost through everybody here. How about Sophian?
Yeah, they have a cold. Usually about that.
What's up?
Sophia has a cold.
Oh, this is Sophian, actually. I have Sophia and Sophian.
Sophia has a cold.
Oh, okay. Well, she can hit me up later. How about Sophia, since you volunteered yourself? Any thoughts from last week?
About paradigm shifts in science, just things that everyone accepted as true and super profound, and then we're just on this kind of nonsense. I'm in an archaeology class as well,
Oh, cool.
and we were talking about the distribution of artifacts Native Americans would have gotten for research, and which holds up for oral history or like the intelligent science. And it just kind of brought an interesting perspective to me to that conversation, knowing that all science is bunk until it's not. Because, I mean, in court, oral history and science are equal. So,
Is that true? Oral history and science are
at
equal.
least in the distribution part.
That's so interesting. Yeah, I've been reading a lot about how most indigenous societies didn't really have anything like court exactly, which is quite interesting. There's a really, there's this going off topic, but it's interesting enough. There's this standard narrative if you take like a sociology class. I don't know, maybe you have an incredible professor, and this isn't the standard narrative, but it's something like there's these two philosophers, Hobbes and Rousseau, who basically had this, if we blend them together, the idea is kind of like well, you know, nature's horrible and rough and everything, so we organize ourselves into these bands of tribes, and then the tribes eventually get to some point where they organize themselves into, well, I guess at first it's just groups of families, then it's bands of tribes, and then the tribes organize them, they start to develop agriculture, and you get civilization as a result because you need to manage all of these people that are now, agriculture allows for lots of people and stuff. And there's an interesting argument, this book that I've been reading by David Graeber called The Dawn of Everything. And he basically argues that that's not true at all, actually. The reality of the situation is that people have been living in all sorts of different ways forever, not just in these sort of formless bands of people, but actually have been organized into really radically different sets of codes. In a lot of indigenous communities, instead of laws, so let's say that I, get in a bar fight with somebody and I kill them. Instead of actually punishing that person, what you do is you actually put the debt of that onto the entire family of the person who committed the crime. And so the result of that is that the individual families keep their own people in check. And so you don't have this distributed punishment system. But there's lots of other examples like that where you have just different ways of organizing society that's not exactly a civilization or just a bunch of hunter-gatherers. There's all sorts of interesting pieces to that that don't involve the traditional progressive narrative, which I find really a relief because it seems like if this is the apex of the way we can organize ourselves, this just seems a little depressing. Like maybe we can do better than this in some sense. So, good points, good points. Let's do one more and then we'll get this thing rolling again.